Hey Mustangs, let's take a look at Novolab Mission 3. So in Mission 3, it's a little bit different from the previous two. In the previous two, in Mission 1 and 2, we looked at morphology in order to decide what was going on. Now we're going to take a look at DNA. Now, scientists use DNA as a more reliable source to determine phylogeny than morphology. Because again, the problem with morphology is convergent evolution, where we see two organisms that don't share a recent common ancestor, and they have similar body structures because of environmental pressures and natural selection. So they develop similar structures that way with no recent common ancestor having those structures as well. So let's go ahead and take a look at DNA. All right, so we have four organisms here, and we can use our magnifying glass once again to find out a little bit about these organisms. And then we have DNA now. So here it actually gives us the outgroup is the Midas cichlid. That's because it has the most differences compared to the other two. So we take a look here, we add it on. Now what we're looking at here is a DNA sequence, and they have, in the second position, they all have C. In the third position, the Midas cichlid had C, but then the other has T. So when we're talking about these letters, we're talking about adenine, thymine, guanine, and cytosine. So that's what we're looking at here. So the cichlid's considered the most distant, so it's the outgroup. And then these two appear to be more closely related just by looking at this DNA sequence. So we add them on. And now we put our, instead of adding the physical characteristics, the morphology to help us determine what the common ancestor had, we're now looking at the DNA. So the common ancestor right here at position 2, that common ancestor had cytosine. So cytosine was found there. And then we had a speciation and branching event. Cichlids went one way, and then this diverged into the other groups over here. So everything after this point is going to have C in position 2. And then over here on these guys, they have T in position 3. So after this branching event, some sort of mutation occurred, and we had a thymine in position 3 instead of a cytosine. So according to this sequence, it appears that the western clawed frog is more related to a coelacanth here. This one tells a little bit more though. So taking a look at this one, again we pull up the DNA, and again we could use the morphology and the information about the organisms and see what they look like, everything. And it says here the outgroup is the great white shark. So compared to all the rest, it has the most different DNA from everybody else. And then we want to take a look and see what else is going on here. So compared to the great white shark, the organism that's most similar to it is the Midas cichlid. After that, we start to see more differences here. So I'm going to put the cichlid next. So they shared a common ancestor, then they branched off. Following them, taking a look here, the West Indian coelacanth, it looks very similar to the Midas cichlid, with a difference being the thymine here instead of the cytosine. So I'm going to put that one next. And then we look at the lungfish and the western claw frog. They have the most similar DNA sequences here. So I'm going to put the lungfish next and the frog last here. Okay. So we go back, and again we identify what did the common ancestor have before they branched and what changes came afterwards. Okay. So they all have in common is in the third position they have a cytosine. From this branching point on, mutations occur, so DNA will change. So what does everything from this point on have? So we take a look at the cichlid. They have it in the fourth position, they have a C. Okay. And then after this branching event, again, more DNA changes, natural selection, mutations, genetic drift, sexual selection will cause these changes to occur here. So next, we have left in position 10, they have an A, or position 1, they have a T. So all three of them have the T in common. And then after this branching event, something changes here, and in this case, you get an A in position 10. Oops, missed up there. And there you go.